So, do y'all know what a crane looks like? Not a train, a crane. Okay, so we've got like the bottom of the crane. I'm not even going to pretend I can draw. Then we've got the arm of it, and then it picks something up, and that's like where the hook hangs down. Okay, so that's where our right triangle comes from. It's a 110-foot crane. So that's like the length of the actual crane. It's set to an angle of 46 degrees to the horizontal. So we'll pretend this goes all the way to a right triangle. 46 degrees to the horizontal. So we put it down at the bottom with the horizontal. It can raise building material to what height? So this is where our X is going to be because it's going to pick something up, it's going to lift it up, and it can't go any higher than the tip of its arm. So the hardest building, could you come back part of that one is drawing that picture. Some people just didn't know what the picture looked like. Alrighty, so we always pretend we're standing at the angle. That's where we are. We're at the angle. Compared to us, what is X? Opposite. And 110? Hypotenuse. Sine, cosine, tan.
So when you put in like the tan 26 and then it's 6 over S, so when you divide, you have to put 6 first.
Alright, where is our variable? Numerator or denominator? Numerator, so we multiply. Get in the habit of just putting the number first, not sine 46 first. Even though with multiplication it doesn't matter either way, but with division it does matter. Now let's talk about rounding. What are we supposed to round to? Nearest hundredth, unless it's an angle, and then it's the nearest whole number. So our answer, did you get 71.93398?
No.
Oops. 100. Oh, I did 100, not 110. 110 times sine 46. 79. Is that better? We'll let me erase. 79.12737. Alright, rounding to the nearest hundredth. So what you do is you look at the hundredths place right there, and you ask, hey neighbor, do I say a 2 or do I bump up? And the neighbor says, what does 7 say? Bump up. It's greater than 5, or it's 5 or greater rather. So our final answer would be 79.13. You don't look at any other places. You don't do a domino effect like this one bumps up, this one. No, you just look at the one place. Yeah, you look at the one place you want to round to, and you just ask your neighbor, do I bump up or this?
If you round it to the tens and it's 12, it would just be 79.10.
If you're rounding to the nearest tens, it would be 79.1. Number 2, the angle of elevation from a ship to the top of the lighthouse. Oh, that sounds like our notes today, right? We had ships in our notes. I'll pretend I can draw. Water. And then we have, let's do a lighthouse. So we're always going to assume it's like the angle that it makes with the water. So this angle right here. The angle of elevation, ooh, that's tiny. I already know that that ship is really, really, really far away. Because that angle of elevation is 3 degrees. If the ship is 1,000 meters from the lighthouse, so that's not going to be the hypotenuse, that's how far away it is in the water. 1,000 meters, how tall is the lighthouse? So just remember, every time, you're going to be drawing a right triangle. Every time start by just drawing a right triangle. Then you can label everything and figure out where the values go. Once your picture's drawn, then you just need to decide, okay, we are on the ship, that is us. What is the lighthouse compared to us? Opposite, adjacent, hypotenuse? Yeah, you're jumping ahead. Yes. So the lighthouse would be opposite, and the water would be adjacent. So we've got our O and our A. So for SOHCAHTOA, that is tan. Tan of 3 degrees equals opposite over adjacent.
So you would multiply?
Yes, ma'am. Very good. X is in the numerator, so we're going to multiply 1,000 times tan of 3. Remember, we're going to round to the nearest hundredth, so it'd be 52.41. Very good. That 7 bumps that 0 up. Oh no. And that is meters. Not divided. So if we're looking at number 7, we've got our tower, and then we've got a stake on the ground, like a nail or like a stake. There. Okay. It says the angle of depression is 72. Now technically, you start at the tower. Depression means you're looking down. So I would go like that. That's my that's my diagonal line. The angle of depression is not here. Not where that star is. Never, ever, ever put it where the star is. The angle of depression is formed with a horizontal. So it goes right here. It's kind of like outside of your triangle.
Could you just draw your triangle like
So you have two options. Look. Option number 1, drop this down right here and boom, you have kind of an upside down right triangle. Option number 2, take that 72 and alternate interior angles, plop it here, and then just use this triangle. That's kind of upright. You can't go wrong. Where do our other values go? Where does 80 go? It's the tower, right? So that's the vertical. That's right here. That's the tower height. And where does X go? Is it the leg or the hypotenuse? It's the leg. How far is the stake from the foot of the tower? Foot means the ground. It means the bottom. So same thing. We can work with either triangle. Compared to 72, it looks like we have opposite and adjacent. Tan 72 equals opposite over adjacent. Oh, good. This hasn't happened yet on this homework. Where is the variable? Denominator divide. So do not put tan 72 first. Put 80 divided by tan 72. 80 divided by tan 72 is 25.99. Yeah. You keep it like that because the 3 tells the 9 not to bump up. And you put feet. We always want to have units on our word problems. Number 4. Let's just start by drawing a right triangle, and then we can make the problem fit our picture. Kite string is 60 meters long, so we want to make sure our kite is flying in the air. It's a windy day, so it's not going directly above us. It's not vertical. This is the kite string right there. So that's key to the kite. We are always going to assume that the kite is not 100% directly above us. It might be an angle 2 degrees, but we're going to assume it's not straight above us because then it wouldn't make a triangle. It'd be a segment, and we wouldn't need to do trigonometry if it was a segment. Okay, so the angle it makes is 42 degrees with the ground. The string is 60 meters. That is the hypotenuse. The string is the hypotenuse. The hypotenuse is the string. How high above the ground? That one's easy. That's the vertical. How high above the ground? Opposite is hypotenuse. Sine 42 equals opposite over hypotenuse. Where is x? Top. Numerator. Multiply. 60 sine 42. 5. Did you round it? Did you get your rounding right?
for sin, instead of like putting the 42 in the picture or whatever.
We're going to look at number 10. The difference in number 10 is that there's 2 boats approaching. So let's draw a lighthouse. I'm going to work down here. Still doing number 10. A lighthouse, and then I'll want a boat, and I'll want a boat. There we go. So each of these, there's going to be a line of sight. If you stare at this boat, it's going to be a different angle than if you stare at this boat. So we kind of have a triangle inside a triangle. The lighthouse is a 50-meter tall lighthouse, so that's the height. So that's that vertical distance, it's 50. The angles to the boats are 39 and 25. Now I could draw the angles of depression up here, but I'm going to choose not to. I'm going to put them down here. Now where do I put the 39 and where do I put the 25?
Does it matter?
Yes, definitely. Think of as you get closer to something, would your angle get larger as you get closer, or would it get smaller as you got closer? Kind of gave you away. It would get larger as you got closer. So which angle should I put here? That, yes, a larger angle. And just picture yourself, you know, with your arms like this, and you're getting closer to something. As you get closer, that angle's going to open up. Anyways, if you were to put them in the wrong spot, you get a negative answer, and you can just change it to positive.
Okay.
So it wouldn't be the end of the world. Find the distance between the boats. So I want you to label this distance right here x. Now the thing about x is that is not a side of a single right triangle. That's a side of an obtuse triangle, you see? So we can't find x right away. Cannot find x. What we can do is we can find, I don't know, what do you want to call it? Let's do A and B. We can find A, because that's the side of a right triangle, and we can find B. What are we going to do once we find A and B? Yes, sir. We're going to subtract them. So we're going to find A, we're going to find B, and we're going to subtract them. I super highly recommend drawing two separate triangles. One where you're going to find A, and another one where you're going to find B. And I drew those wrong because the A is bigger, but it doesn't matter. Yeah, this is one of the harder ones. We did all the easy ones already. Okay, this is the harder one. This is the hard. All right, in both of these triangles that I'm drawing separately, this is 50 and 50 because the lighthouse is not going to change height. So this is 39 degrees and 25 degrees. All right, all you need to do trig is two pieces of information. For A, we know the angle and a side, so we can do trig. We're going to use the same equation both times. What equation? Or what trig function? Tan. Opposite, adjacent. Opposite, adjacent. Yep. All right, let's find the larger one first. Let's find A. Tan of 25 degrees equals opposite over adjacent. I'll go ahead and write the other equations. The same exact thing, almost. Tan of 25 degrees equals opposite. Nope, not 25. Stop me. 39. There we go. Where is the variable both times?
On the bottom.
Denominator divide. Don't call it the bottom, call it the denominator. That way it'll start with a D. Yeah. Denominator divide. So 50 divided by tan 25. 107.225. And 50 divided by tan 39. 61.7448. What are we doing with those again? Subtracting them. If we take A and we subtract B from A, we are left with X. And that is the distance between the boats. And that's as hard as we can make this on you guys. Final answer.